Good morning. Today, this will be your first class for class 8th. So, I'm starting it with rational numbers. Now, what are rational numbers? Before studying that, we will study what actually is number system. So, let's check it out. So, this is your number system. In your number system, you first have natural numbers, which starts from 1 to infinity. Then second we have whole numbers. Whole numbers actually, when we add 0 to a natural number, it becomes whole number. So all the numbers from 0 to infinity are whole numbers. Then we have integers. Integers are positive and negative both. All the positive and negative numbers together becomes integers. So if we add negative numbers, like in whole number, it will become integers. Now after integers, we have rational numbers. So what are rational numbers? When we add fractions to integers, they become rational numbers. Rational numbers now which we have to study are all numbers which can be written in the form of p by q, where q is never equals to 0. Q will be never be equals to 0. After this, we have irrational numbers. Irrational numbers you will study in class 9th, but still all the numbers which cannot be written in p by q, they are like numbers which are under root 2, under root 3, under root 4, under root 5, value of pi, okay, 1 minus under root 2, all such numbers are irrational. Now why are they irrational? Except them, there are many other numbers which are decimal numbers and they are non-terminating. The term non-terminating will also be in class 9, but still the small information about that is, if I write a number 0.33321112 and carry on with some other numbers. Such type of numbers which are never ending and non-terminating, they are called irrational numbers. Okay. Now after studying what are rational numbers and irrational numbers, altogether rational and irrational becomes real numbers. So all the numbers comes under the category of real numbers. Now second portion, if we see it like this, or in this way, it's a better way. This is real number. All real numbers are rational, irrational, integer, whole, natural. Real numbers are everything except complex numbers. Now what are complex numbers? Complex numbers are when a number is a negative, under root of any negative number is a complex number, like it is described with I, which is known as iota, and the value of iota I is under root minus 1. Now back over here, we have, when we go into this circular zone, the answers will be yes. Now see how. If I say all rational numbers are real numbers, if I go out and say all rational numbers are real number, then it is yes, all rational numbers are real numbers. But if I say all real numbers are rational, no, because some of the real numbers are also irrational. So if I say all natural numbers are whole numbers, all natural numbers are whole numbers, yes, sorry, all natural numbers are a part of whole number. But on other way, if I say all whole numbers are natural number, no, because 0 is a part of whole number, but it is not a part of natural numbers. Similarly, if I go over here, all integers are whole numbers, no, because integers are positive as well as negative, where whole numbers are always positive. All rational numbers are integers, no. All integers can be rational numbers, but all rational numbers are not integers. Now sometimes student ask, if rational numbers can be written in the form of p by q, then how 2 is a rational number? Because if we can write 2 as 2 by 1, we can write 2 as 2 by 1, so this is also p by q form. Now let's go to small presentation section. What are real numbers?
So let's talk a little bit about rational numbers. Rational numbers. And the simple way to think about it is any number that can be represented as the ratio of two integers is a rational number. So, for example, any integer is a rational number. 1 can be represented as 1 over 1, or as -2 over -2, or as 10,000 over 10,000. In all of these cases, these are all different representations of the number 1, ratio of two integers. And I actually obviously can have an infinite number of representations of 1 in this way, the same number over the same number. The number -7 could be represented as -7 over 1, or 7 over -1, or -14 over +2, and I could go on and on and on and on. So -7 is definitely a rational number. It can be represented as the ratio of two integers. But what about things that are not integers? For example, let us imagine, let's imagine 3.75. How can we represent that as the ratio of two integers? Well, 3.75, you could rewrite that as 375 over 100, which is the same thing as 750 over 200. Or you could say, hey, 3.75 is the same thing as 3 3/4, so let me write here, 3 3/4, which is the same thing as, that's 15 over 4. 4 times 3 is 12, plus 3 is 15. So you could write this. This is the same thing as 15 over 4. Or we could write this as -30 over -8. I just multiplied the numerator and the denominator here by -2. But just to be clear, this is clearly rational. I'm giving you multiple examples of how this can be represented as the ratio of two integers. Now, what about repeating decimals? Well, let's take maybe the most famous of the repeating decimals. Let's say you have 0.333, just keeps going on and on forever, which we can denote by putting that little bar on top of the 3. This is 0.
Now this part of rational numbers will be covered in class 9th. How to convert irrational repeated non-terminating recurring decimal numbers into rational number. This is a part of class 9th. So we will move to another topic now. Next topic of your same rational number chapter. Now let's go to your NCERT. and has the first property of rational numbers. As you get to know, rational numbers are in P by Q form, where Q is never equals to 0. And you can change any type of number, means any type of integer, whole and natural number into rational number. You cannot convert rational numbers into integers, but yes, you can convert integers into rational numbers, whether they are positive or negative. If they are positive, let's say 4, so you can write 4 as 4 by 1, or 8 by 2, or you can say 44 by 11. All these are actually, this is an integer 4 which can be converted into rational number form. Or if it is negative number, let's say negative 4, it can be written as negative 4 by 1, or 4 by negative 1, or 8 by negative 2, or negative 8 by 2. In any form you can write. Now after this, if the number is in decimal form, then there are 3 types of decimal numbers. First are terminating decimal numbers, like 0.34. This is terminating decimal number. This can be easily converted into rational form. Let's say 0.34 will be equals to 0.34. Removing the decimal 2 places, you will get 100 at the denominator. So it will be 34 by 100. Now next is non-terminating decimal numbers. And go on. This is non-terminating decimal numbers. These type of numbers cannot be converted into rational form because they are irrational. They are irrational. So they cannot be converted into rational form. Now third type of numbers are non-terminating reoccurring. What are they? Let's say 0.424242. So if you see, you will find that 42 is repeating again and again. So these type of number are also non-terminating decimal numbers, but non-terminating reoccurring decimal numbers. They can be converted into rational form. But this is a part of class 9th. When you convert, you have to write non-terminating decimal numbers as 0.42 bar. This bar states that this is repeating to the infinity. Now this we will study in class 9th. Right now, what is there in your NCERT, we'll get back to it. Now, first, there are some properties of rational numbers. What are they? First property is closure. Closure property. What is a closure property? Actually, closure property states that if you are taking same number and you are adding them, it will also give a same type of number. They are total. You have to study property for whole numbers, natural numbers, integers, and rational numbers. Let's say we will study it for whole number first. First is whole numbers. So what are whole numbers? Which starts from 0, 1, 2, 3 up to infinity. This is a sign for infinity. Whole numbers are those which starts from 0 and still infinity. If we add two whole numbers, it will give a result of as a whole number only. let's say if I write 0 plus 6, it will give 6, which is again a whole number. Or if I write 6 plus 0, it will also give 6. So closure property works for addition in whole numbers. Closure property works for addition in whole numbers. Now next, for the same we'll do, first we have done addition, next we will do subtraction. In subtraction, if I write 0 minus 6, it will give minus 6, which is not a whole number. Or if I write 6 minus 0, it will give 6, which is a whole number. So in some cases it might not give you a exact result. So in that case we will say that this closure property do not work. This closure property do not work under subtraction of whole numbers. Now next, for multiplication, if we do the multiplication of these number, 0 into 6 will gives you 0, and 6 into 0 will also gives you 0. If we take something else like 3 into 4 will gives you 12, and 4 into 3 will also gives you 12. Hence, yes, it works. Closure property works in multiplication in whole number. And if we check for division, what we will get? Let's say if we check it for division, let's say 6 divided by 2 will gives you 3, and 2 divides by 6 will gives you 1 by 3. So both the result are not same. That means closure property do not work in division. It will not work. For division case, it will not work. One very important point over here, if I ask you to write 0 in a rational form, you can write it as 0 by 1. But if I ask you what is the value of 1 by 0, then such value is not defined, not infinity. This will be always not defined. And in this case, you will write it as 0. And when 0 is divided by any number, it always gives 0. By any number you can take. But when any number is divided by 0, it is always not defined. Now, to next topic. Now next is for integers. If you will check the property, closure property for integers, you have to check it for first for addition, then for subtraction, third multiplication, fourth division. We have to check it for 4. Let's say first we'll check it for addition. If I say what are integers? Integers can be negative, from negative infinity, negative 2, negative 1, 0, 1, 2 till positive infinity. All such numbers are integers. Over here if I write 6 plus minus 3, it will gives what will it give? It will give you 6 minus 3 means 3. And if I write minus 3 plus 6, it will also gives you 3. Both the results are same. Yes, it works. Closure property for integers in addition works. And if we do the subtraction, 6 minus minus 3 will gives you 9. Why? Because over here it becomes 6 plus 3. Negative negative will become positive, gives you 9. Now next, if I write it like this, minus 3 minus 6, it will gives you minus 9. The result will be negative 9. So again it is also an integer, though the result is not same, means both are not 9, but both are integers itself. If this is integer, this is also integer. So yes, it also works in subtraction. It works in subtraction. This is just a closure property which only requires that if you are adding integers, it will give you integer. If you are subtracting integers, it will give you integer. What if we do the multiplication? 6 into minus 3 will gives you minus 9, and minus 3 into 6 will also gives you minus 9. So in both the cases, when we are multiplying two integers, we are getting integers only. So yes, it also works in integers. Now in division, in multiplication it works. Now in division, if I write minus 3 divide by 6, it will gives you minus 1 by 2. On the other hand, if I write 2 divide by minus 3, it will gives you minus 2 by 1. Over here, this is irrational number. This is a rational number, but this can be considered as integer. But this one is rational number. So when we are dividing two integers, in some cases it is giving integer, but in some cases it is giving a rational number. So no, it do not works over here. Closure property for integers do not work in division. Now next, after integers we have real numbers. Now what are real numbers? All the numbers including p by q form, negative, positive, 1, 2, 3, 0, etc., etc. Everything which is under integer, whole number and natural number is a part of real number. Okay, but in this we will study first rational numbers. First we have to study rational numbers. So what are rational numbers? All in p by q form, where q is never equals to 0. So let's see, we have to check it for addition. Subtraction, multiplication and division. First let's add. If we add two rational numbers, let's say 3 by 2 plus 4 by 5, what it will give to you? The LCM will be 10 on above. 3 into 5, 15, 4 plus into 2, 8. The result will be 15 plus 8 gives you 23 upon 10, which is again a rational form. So yes, closure property works in addition in rational numbers. Now to subtraction, if I write (3 by 2 minus 4 by 5), then the result will be 10 upon 23 minus 8. That will gives you 15 by 15 minus 8. This will gives you 15 minus 8 will gives you 7 by 10. So again it works for subtraction also. Now for multiplication, if we multiply, it will give again 12 upon 10 is a rational form. Yes, it works for rational numbers also. Now we will check it for division. It is important. Why? I'll get it back to you. If we divide 3 by 2 divide by 4 by 5, we'll get 3 by 2 into 5 by 4. This is what we can write. We can change the division sign into multiplication and inverse the ratio. It will become 15 upon 8. This is a rational form. This is a rational form. So by looking at this, we can say yes, division also works. But the important point is, if we divide any rational number, let's say 1 by 2 divide by 0, any rational number by 0, then it will always be not defined. Because I told you, when we divide any number by 0, it becomes not defined. So due to this case, it do not works in division. The closure property for rational number do not work in division. Do you remember this? Now we will study the next property, that is commutativity of all these type of numbers. So what is commutative property? Commutative property states that, let's say if there are any number A is added to B, it will gives a same relation, B added to A, the result will be same. Let's say 3 plus 2 is 5. Similarly 2 plus 3 will be 5. Okay, this is for addition. Okay, now next is for subtraction. Subtraction will be state A minus B will be equals to B minus A. Any number is subtracted from a number will give you a same result if we reverse them, the order. So let's check it out. 3 minus 2 will gives you 1, whereas 2 minus 3 will gives you minus 1. So you have to check this also. So if I take it, because these are actually whole numbers, these are whole numbers. So in whole numbers, addition, commutative for addition works. Yes, it works. But over here it do not work, because over here the result is coming 1, and when we interchange them, the result is coming -1. So the result is not same. So we can write no, this do not works in whole number. Let's say for multiplication, if we write A into B should be equals to B into A. If both the results are equal, it will work. If they are not equal, it will not work. So let's say 3 into 2 gives you 6, and 2 into 3 also gives you 6. So for whole numbers, it worked. For whole number, it worked. For division, let's check. A upon B should be equals to B upon A, or we can write A divided by B will be equals to B divided by A. Then this property works. Does it work? Check करते हैं. 3 divided by 2 gives you 3 by 2, whereas 2 divided by 3 will gives you 2 by 3. As both the fractions are different, therefore answer will be no. This do not works in division. Okay. Similarly, for commutative, you have to check, this is your homework, you have to check this property in integers and in rational numbers. The same way we have done for closures. For each and every one you have to check first for addition, then for subtraction, then for multiplication, and then for division. Over here I have taken whole numbers. In integers you will take 1 positive, 1 negative, then check it. In rational numbers you will take it 3 by 2, 5 by 6, in this way, in P by Q form. Now after this there is one more property, which is associativity, Now what is associativity? Associativity states that if we add any number in this form, a plus bracket b plus c, this will give us the same result, a plus b plus c. This is for addition. Now you have to check putting whole numbers, integer and rational in this. If the identity is proving itself, then it is yes. If it is not proving, then it is no. Then for subtraction, it will be a minus b minus c. It should be equals to a minus b minus c. You need to check this also by putting whole number, integer and rational. In each case, if it worked, then it is a correct answer. If it did not work, then it is a do not work for this one. Then for multiplication, a into b into c should be equals to a into b into c. You have to check for this also in the case of whole number, integer and rational. Last is division. This also you will check. Division will be a divided by b divided by c should be equals to a divided by b divided by c. Now you have to check all these with whole numbers, integers and rational number. For all three you will check all these 4 different associative properties. With this I am ending your class, and this is your homework for today. Is that clear to everyone? So as today's topic ends with this, you have to do this at home now, and we will continue the next topic on Friday. Thank you.